All right. Good morning again, everyone. This is part two. I just want to quickly go over, just in case you missed it from the bottom, from the first video. We were going over the equation or rule. So right here, both sequences above can be described by the rule of a sub n equals 2 times n, or f of n is equal to 2 times n, or 2n. So basically, I was explaining in the video that right here, when you have 2 being the first digit here, this is considered your a1. This is your A2 and A3 and finally A4. So this is a finite sequence because it ends here at the 8. So notice that you go from 2 to 4, right? You multiply it by 2. 2 times 2 will give you 4, right? And so right here, you have A is 2. So basically you're multiplying 2 times 2 to get you the 4 here. And then you're multiplying 2 times 3 to get you the 6. So notice that the sub number right here, 1 times 2 is 2, 2 times 2 is 4, and then 3 times 2 is 6, and 4 times 2 is 8. So that's how we came about the rule. 2 times whatever n is. So in this case, n is 1 again. So 1 times 2 is 2, 2 times 2, 4, n is 3 here, 3 times 2, 4 times 2, and so on. So same thing for this one, since it's the same thing, except this one doesn't stop. It's an infinite sequence, so it's gonna go on forever. And so we'll talk about more as we continue. All right, now I wanna go ahead and move into our new lesson in terms of examples. So right here, we're gonna write out the first example, example 1. And we're gonna write down, the directions are write the first 6 terms. Write the first 6 terms of, let's do a sub n equals 2n plus 5. Okay, and we're also going to do question B. F of n is equal to the quantity of -3 to the n minus 1 power. Okay. All right, so let's look at the question again. It says, write the first 6 terms of a sub n equals 2n plus 5 and f of n equals to the quantity of -3 to the n minus 1. Okay, so how do we find the first 6 terms? Okay, so the first 6 terms again, we think about n, right? So n is 1. So when n is 1, what happens? We're going to substitute 1 for n. So everywhere we're seeing n, we're going to put a 1 for this one. So when you calculate this, you're going to get a1 is equal to 2 plus 5. And 2 plus 5 is 7. So I just found my first digit of my sequence. So a1 is 7. So you're going to do that all the way until you get to all 6 of them. So all 6 of them meaning that we're going to go to a6. Okay, so a2 will be what? 2m plus 5. So 2 times 2 plus 5 is equal to 4 plus 5. And that gives us 9. Okay. So again, all we're doing is finding the first 6 terms. So that means we're substituting the n value in here for our equation. So again, right here in this case, n is 3. So we're going to substitute 3 here for n. Calculate using order of operation. 6 plus 5 is equal to 11. So a sub 3 is equal to 11. A sub 2 was 9, and a sub 1 was 7. All right, so hopefully you got the hang of this already. So notice, you could already start noticing the little pattern, 7, 9, 11. All right, so what do you think the next one's gonna be? Yep, you guessed it. It's gonna be 2 times 4 plus 5, which is equal to 8 plus 5. 13. Boom. And we're going to do it 2 more times. So you got a sub 5 is equal to 2m plus 5. And notice we're going to get 2 times 5 plus 5, which is equal to 10 plus 5, which is 15. So at this point, okay, you can continue showing your work for the last one. A sub 6. So a sub 6 will give us 2 times 6 plus 5, which is equal to 12 plus 5. and that will give us 17. So a sub 6 is equal to 17. So look at that. You just found all 6 terms. So n1, 7, n2, 9, n3, 11, n4, 13, n equal to 5, 15, and n equal to 6 is 17. Okay, now it's your turn. Okay, go ahead and try this one before we do it together. Go ahead and pause the video, and then we'll continue from there. Thank you.